My name is Turner, and here is the burner cabinet project. So over here, we have two heating elements and a blower fan, and we have 3 temp sensors that track the temperature of this heating cabinet. So there's a bunch of buttons on this panel I got right here, but all we need is we have an e-stop, a reset button, and then a start and a stop right here. So we're going to start it up right now. And then if we turn our selector switch to the left, that turns on the first heater. And if we turn it to the right, it turns on both heaters. And you can see that all represented in my HMI up in the corner here. And so these different temp sensors, I'll show you where I have them all positioned. So they're actually housed under here, or the temperature transmitters are housed under the cabinet, and then their wires are run along here to these temp probes. So my first one here that tracks my after the heating element, and then I have a pressure sensor right here that measures the difference in pressure before the blower and after the blower. And then this is my room temperature probe that tracks the temperature of the room. And then right here is the before temperature probe. And that's about it for the walkthrough. Pretty simple device. You could use it to heat up a shop or anything in classroom. And then we can turn off the heaters by just turning the selector switch to off. And this blower is going to run until this temp probe is within 5 degrees of this temp probe, because we don't want to have all the heat in those coils. We want to get all that heat out so we don't melt something or cause a fire. We also have this airflow switch that helps me track in my PLC program that we actually do have airflow coming through. And yeah, so this thing's gonna run until that temperature gets within 5 degrees, and it's gonna be running for a while, it looks like. But we'll move on to my CAD and PLC programming. All right, so here we have my CAD drawing. Right here we have our blower motor and the contacts that are used to start it. Same with the heating element. We have 2 phases going into the heating element. Our output card for our .io. These outputs power the power on the heater contacts. Then we have our 4020 milliamp analog input card for our temp sensors, 2 of our temp sensors, and then the other one is for one of the temp sensors and the one pressure sensor we have. And this right here shows my disconnect and how it goes through the transformer. And then our 24 volt power supply. Here we have our blower contact that's powered from our relay. Our digital input card. This is how we tell whether the e-stop, stop, start, reset's pressed. And then we have our selector switch down here. Here's our frequency drive. It's powered with 3 phases, and then those 3 phases end up going to the motor. Then I originally was going to do this through Modbus, but didn't have enough time to kind of figure that all out. So I just have an output from my .io that when it's connected, it activates this start forward right here. And then we just have this running a common right here. This is 24 volt control. Here's my e-stop circuit. I have a e-stop, a reset, this control relay, and a holding contact.
And then my different transmitters, they're all the same wiring, except for the pressure sensor doesn't have a temp probe it's going out to, but here's my 3 temp sensors and then the pressure transmitter. So now I'm gonna go back in the cabinet and show all these components and where they are in my cabinet. So let's go do that. All right, so we're gonna go check out all the components of this cabinet. So first, we're gonna go to my disconnect. We'll turn it off, and we have 208 coming in right here with 3 wires, and then 208 going to my panel. So, coming into my panel, our 208 lands right here and then gets distributed. We need this 3-phase to power our blower motor. We have a 3-phase blower motor, and then each of the heaters are 2-phase. So it comes out of here, we go through our transformer, and we step it down to 120, and we use this 120 to power our relay contactors, or our relay in general, and then also to power all these contactors. So when I hit my reset button here, we can see this relay actuates, and so does this blower starter, and that's all run off 120 volts. So then we have our frequency drive. This is just powered, it's powered with 208, 3-phase, and then this is what starts the frequency drive forward, and that's just powered with this relay output card. And then we have it just running back to 24 volt common. Then we have all these black wires coming out of this relay output card, powers these 2 contactors for the heaters. Then we have then we just have this point IO, this ProSoft Ethernet to Modbus converter I ended up not using because I couldn't figure out Modbus. This is just our DC power supply, and that's about it. We don't have many components here. It's all pretty simple, but that's it for the components in this panel. All right, so now we're going to get into the programming of this thing. So this first rung here is just a simple start-stop circuit, and I'll turn on this turn-on bit. And this turn-on bit will turn on the blower as long as the e-stop isn't pressed. And then we have this greater than. So I have a temp probe after the heater and before the heater. So when we want to stop this thing, we don't want all that heat in the heater coils to stay there, maybe melt something or start a fire if there's no air blowing through it. So the blower will keep blowing if the after heater temp is greater than the before heater temp. And I also have a compute instruction down here just to subtract that after heat temp by 5, just so it doesn't have to be exact, but as long as it's within 5 degrees, the blower will shut off. So then I just have a little on delay timer. When the blower turns on, I let it blow for 3 seconds before it can turn on any heaters. That's just basically making sure we have airflow. And so this right here is a airflow switch, and it comes with a normally open and normally closed set of contacts just for redundancy. So if both of those are, one's false, one's true, this airflow bit will be true. And so this thing's kind of inconsistent. It's got that little fan on it, and when the blower blows, the fan kind of kicks up, and it's not always accurate. Sometimes it flickers back and forth. So if it's not true for more than 3 seconds, we have this no airflow timer, and that'll shut off the power to our heaters. And here we have, if the selector switch is turned to the right, both heaters will run. If it's turned to the left, just one heater will go. So, and then the rest of this program is just compute instructions, just dividing our raw data we get from our temp probes by 100 to get these degrees in Fahrenheit to make it more readable. And then I have a scale with parameters for my pressure sensor to get the correct PSI. But that about wraps it up. Thanks for watching. This is my last video for the SCADA lab, so see you later.